So, cubic models. Find the function that prints the graph with x-intercepts on a given point. So, okay, so we know that we can insert a math box. A times x plus 3. Since you have x equals negative 3 will be 0. When I factor, a negative 3 plus 3 will be 0. We also have x plus or minus 1 and another factor x minus 4. But this is a quadratic, not a cubic. So where do I get the extra factor? Well, right here, locally right here, at x minus 1, that's actually, I have to write that twice because it acts like a quadratic. It's said to bounce off the axis. While these act linearly, this is a line through here. So this is why I write it this way. And this is f of x, or our model. So model, and we can define it. Define. Oh, but it didn't like it because I need to figure out a. So it's a positive direction. Question is, which one is it? We have answers here. This has an a of 1. This one doesn't work because the square is in the wrong place. So x plus 3, x plus 3, x minus 4. It's either B or C. Is it 3 or is it 1? So it could be just 1. That's what F then. And then, so f of 2 is 24. I mean, f of 2 should be 24, and it's not. So going back here, if I multiply this by, actually it is negative 10, so that works. Well, if you put 3 and try f of 2, it's negative 30, it doesn't work out. So 1 works out. Oops, 1. And apparently I don't need to check twice. So I have my model, and this was extra. And at 0, obviously, we could try f of 0. Well, we can substitute a whole list. So control right, we can try negative 3, comma 0, 0, comma 1, comma 2, comma 4 to check all the points, and you'll see that 0, negative 0, negative 12, 0, negative 10, and 0 match up quite nicely. So it works. That's my model. So I can just choose it. And next. Now if you want to see the graph, For the data, you have to put in the points like we had. Let's get rid of that extra. Zero, -1, 0, 1. I think that was actually -2, right? -3, 0, 1, 2, 4. And the y's are supposed to be 0, oops, 0, -12, and you'd have to insert more columns to see the difference. It needs to be 4 differences. Well, maybe I should put D4 instead at this point. New data. Anyway, what's the model? Well, model is our function f. Nasty. Make sure your data's cleaned up. Problems otherwise. There's a nice lunch. Anyway, and of course a graph. Where the points go through. Where'd you expect them to? Zoom out if you want. Anyway. Come back to this data. Let's see. This problem here. .295, 8.53, 2.01, 0.27, 2.90. First difference is, second difference is, oh, that seems to work. No, those are the first inputs. And third, but this is just in the power regression model. So here are the choices. Well, this would be x to the negative 1 or negative 2. It says right here, Sue and Betty gathered data at the table below 100 watt light bulb. Okay, with a light intensity probe. It's just watts over the distance squared. So just by the measurements, it looks like it would be either this one or one of these two, because the x squared. So let's do the regression here on the side right here, or do it here. Show power and delete the other one. (7.93 to the negative 2, more or less. That's it. Oh. I could have seen that. Well, obviously if I do x times y squared, x times y, doing the algebra backwards. Okay, didn't like that. xy. How do we do that? What does that mean? It's a times b. And that's what it looks like there, according to the data. Does that look constant? One, two, 7.9, 7.9, 8, 3, 4. I don't know. Leave that for that. So, model is equal to 7.93 divided by a squared. Whoops. Leaving with this residual. Now these just means close to zero. Close to zero. Some error. 2.75 meters away. Well, that's easy enough. Add it to the model. 2.75 according to the model. 1.05. Next. Find the function of the following graph, the x-intercept at given point. This is a cubic, and it's positive. So, well, just need to know how to stretch it. So again, go here. X plus 3, x minus 1, and x minus 4, but there's only one of them. And I have to decide what happens at those points. At 3, 0, 1, 2, and 4. Supposed to be at 30, so I multiply it by 3. This ends up to being at 36, which matches here. And of the 0, anything times 0 is 0, negative 30 is there. So that seems to work just fine. So that's my model. Just go here. Actually, I don't even have to check that. It's 3 times x plus 3, x minus 1, x minus 4. X plus 3 for this point, x minus 1 for this point, x minus 4 for that point. And if you leave it alone, don't put the 3. This is negative 10 here, but stretching it by 3, so that's the one. Similar. Let's see. X minus 4 requires x plus 4 here. And then a 1, 5, I don't know, 2 and 3. This is 2, this is 3. So I want to check at negative 4, 0, 2, well, also 1, and 2, for 5, and 0 and 3. Negative 4, 0, 1, 2, 3. Negative 4, 0, 1, 2, 3. That's what I need to check. But first, to find the function, and then get the output. So those are my zeros, 24 and 10. So 24 is too high. And 10 compared to 5, that should be half. So go back to half. Whoops. I said, if you look at these, it should be a half version. There it is. So 0, 12, 5, 0, 0.